Okay guys, welcome to Learn Mathematics today with the Great. So we'll be starting with a series on differentiation, as this is a very important and crucial aspect of mathematics. But if you feel that you need some explanation in a particular topic, or you feel we should talk more about it, feel free to give your comment below. And if you are watching this video, don't forget to subscribe to our channel and click the notification bell so you'll be notified. Yes, notified when new videos are being uploaded. So let's move on. So the first thing we'll be talking on is the gradient of a straight line graph. The gradient of a straight line graph. So the gradient of a sloping straight line is defined as the vertical distance the line rises or falls between 2 points. Okay, then we are going to divide that by the horizontal distance between the 2 points. That's okay. That's the gradient. So if I want to illustrate this on a graph, let's draw a graph here. Don't mind this rough sketch. So here we have the y-axis and here we have the x-axis. So do a straight line graph. So let me pick 2 points. This is a point, this is a point. Let me call this one point P and call this one point Q. So trace it down here. Okay, where P here is a point to the left of point Q on the straight line graph. Let me call the graph AB. Okay, and the graph slopes upward, obviously, from left to right. So the changes in the x and y values of the point P are denoted by the x and the y. So let me put it here. Here we have the y, and on the x-axis we have the x, respectively. So the gradient of this line is given by the y dx, and it has a symbol of m. Pick a red color. So the gradient is denoted by m and is equals to the y over the x. Now the gradient of the straight line is actually constant throughout its length. So for example, if I should give a value for, let me say, let point P have a value of 4,6, which actually implies that 4 on the x-axis and y, and 6 on the y-axis. And my point Q, let's say my point Q has a coordinate of 8,7. Okay, and if we want to express the gradient here, so we just find the change in the y value over the change in the x. That's what it's talking about. Don't forget This first for point P, the coordinate is labeled as x comma y. Y for point Q is also labeled as x comma y. So we can differentiate it. Let's call this one x1 y1 and x2 y2. Okay, I hope we got that. So now if we want to express this as a gradient, let me close this so we can see. Now we have point P as 4,6 and point Q as 8,7. So our slope, don't forget, we define it as the y, the x change. So we are going to have 7 minus 6 over 8 minus 4. So this is 1 over 4, and in decimal is 0.25. Okay, that is the gradient of the point P to point Q on using the point P and point Q of the line. So if you wish to express it on a straight line graph, you can also draw your graph as the case may be, and pick your scale. Let me use scale of 2 units here, 2, 4, and the y-axis 6. I think that's the maximum. On the x-axis I have 2, 4, okay, 6, 8. So if I want to pick my point, my point P, that's x is 4, y is 6. So I think they should fall somewhere. Yeah. Okay. And the other point Q, that's on the coordinate of x is 8, y is 7. So let me increase the coordinate of this by, let me add 7. So we have 7. Okay, so we have this here. So 8,7, something like this. So let's see if we can combine the two. So okay, this is how it's actually supposed to look like. Let's forget the rough sketch. Now what if we are actually given other points? So let's say if we were given, find the coordinate for point, let me take another example, point P to be minus 3,6. That is the big bracket, and point Q to be 5,2. So we know that our M is the y dx, which is equals to 2 minus 6 over 5 minus minus 3. So we are going to have minus 4 over 8 in this case. So we have minus 1 over 2. And in fraction, this is in fraction, in decimal, we are going to have 0 minus 0.5 minus 0.5. Oh, that is how we evaluate the gradient of a straight line. So if you are actually giving it as points, or it is located on a graph, so this is the way it will be evaluated. So in the next lesson we'll be looking at the gradient of a curve at a given point. How are we going to evaluate that? So it's quite different from that of a line, because the curve varies along its length. So because of this, so the variance of a curve is not defined. So don't miss the next lesson. So feel free to ask your question or give comments below. Thank you guys for watching. Hope to see you guys in the next